Okay, in this recording I'm going to go over your acceleration homework that we assigned the other day. It's the first question says identify each of the kinematic variables below. And so T, of course, stands for time. Delta X, let me zoom in a little bit here. Delta X stands for displacement, which is also, by definition, the change in position. So it's going to be the difference between your starting and your ending position, not necessarily the total distance traveled, but the change in your starting and ending position. V naught is your initial velocity, and V is your final velocity. A, of course, is your acceleration. And real quickly, I know the question didn't ask this, but I'm going to go ahead and identify the units for each of these. Time is always going to be measured in seconds, or answer should be reported in seconds. Displacement is going to be meters. Initial velocity, meters per second. Also final velocity, meters per second. And acceleration is going to be meters per second, which a lot of times you'll see written as meters per second squared. Number 2 says state which variable is missing from each of the kinematics equations below. Notice that every one of these equations has acceleration in it. So these equations are going to be used for constant acceleration. And if you're asking, well, what if there isn't any acceleration? What if it's not accelerating at all and it's constant velocity? Well, plug in a 0 for the A here, and you get 0 times t is 0. So you see that your initial and final velocity are equal to each other. Makes sense. Plug a 0 in here for this acceleration, and this whole part of the equation becomes 0. Then we get delta x equals v naught t. Well, there is no initial or final because the velocity is constant, so it simply becomes x equals vt, which is the first equation we derived in physics class. And of course, again, if we plug in 0 here, we get the initial and final velocities are equal to each other. So just know that these are for, this is for motion that is accelerating, and if it's not accelerating, then you would want to plug in a 0 for this equation and get delta x equals vt. All right, what variables are missing below? Here are the variables that I'm looking at, and I can see that the first equation does not have displacement. There is no delta x in that first equation. And the second equation, it might take you a little bit to figure it out, but it is the final velocity. We do not know the final velocity if we use that equation. And then for the last one, the variable that's missing is time. So the reason that we have multiple kinematics equations is so that if we don't know one of our variables, we can always use different equations to figure out what we need to know. So the first question says Kendall and Elena are driving to school one morning traveling east, so there's our direction, but they are running late. As a result, they're speeding, doing 46 meters per second in a 25 meter per second zone. Sure enough, Boerne Police Department catches them. It takes them 5 seconds to pull over to a complete stop. What is the magnitude of their acceleration? So what they want me to find is the acceleration. The first step to solving any physics problem is identifying your knowns, and 46 meters per second is a known, and I'm going to identify that as a variable. What variable? Well, I'm going to pick one of these from the list in number 1. And 46 meters per second is their starting speed, so I'm going to label that as v naught. The next bit of information they gave me was 25 meters per second zone. That is a value that's not needed in my calculation. That was just telling me what the speed limit sign said. 5 seconds is my next variable, and that of course is going to be time. And they want to pull over to a complete stop. Highlight that complete stop. That is a key word. So they didn't give you a number there, but we know that we came to a complete stop. So my final speed is 0. Finally, they want to know what the magnitude of the acceleration is. So what I've done so far is I have identified my knowns. Now I need to identify my unknown. What are they asking me to find in the problem? And that is acceleration. So I'm going to put a question mark there because I don't know what it is, but I'm going to go ahead and list that variable. Now what I'm going to do is I'm going to look at these variables right here. I'm going to highlight them for you. Those variables. And then I come back up here and I look at my list of equations and I ask myself, which equation has these variables in it? V, V naught, A, and T. Well, we can quickly see that it's going to be this equation right here. V, V naught, A, and T. So now I come down here and I write my equation. V equals, AT plus V naught. Let me erase that. AT plus V naught. Now I rearrange to solve for my unknown. And in this case, acceleration is my unknown. So this is where your algebra skills come in. I want to isolate A, which means I want to get A by itself on one side. So the first thing I have to do is I have to go in the reverse order of, please excuse my dear Aunt Sally. So the first thing I want to do is I want to get rid of this plus here. So I'm going to subtract V naught from both sides. So I get V minus V naught equals AT. And then to get A by itself, I divide both sides by T. That cancels out. And now I have V minus V naught equals AT. Now that I have isolated for A, all I have to do is plug in based on these numbers I have over here. It makes it super easy when you do it this way. And if you make a mistake here, it's easier to fix the mistake if you have it left in variable term before you plug your numbers in. I know a lot of you are probably going to want to plug your numbers in up here, but it really does help in the end if you wait till the final step to plug numbers in. So we're going to have 46 minus 0 divided by 5 equals A. So I'm just going to get my calculator out and see what 46 divided by 5 is. That comes out to be 9.2. So I'm just going to continue my space up here and say 9.2, and then the unit for acceleration is meters per second squared, and that is equal to my acceleration. So that is the magnitude of their acceleration, 9.2 meters per second squared. Magnitude is simply the value. So that magnitude is 9.2. The next part wants to know what the direction of their acceleration is. And that's what makes acceleration a vector, is that it has magnitude and direction. So I have to ask myself, what direction were they originally going, and are they speeding up or slowing down? Oh, you know what? I just found a mistake. Up here, it should have been 0 minus 46. Let's cross that out. That should have been 0 minus 46 because it's final minus initial, and my final was 0. I bet a lot of you caught that. If you did, good job. So it should be 0 minus 46. So I should actually have a negative 9.2 meters per second squared. So that negative just means that my direction of acceleration is opposite the direction of my motion. And since my motion is to the east and I'm slowing down, my acceleration vector is to the west. All right, number 4. Gavin is driving down Main Street with a velocity of 36 meters per second. Should say when his engine suddenly stops. He comes to rest 6 seconds later. Calculate his acceleration. Sorry, Gavin. So I identify my knowns. The number is given to me in the problem. 36 meters per second. That's going to be initial velocity. His engine suddenly comes to a stop. He comes to rest. So another key word there, rest, comes to a rest. That means that his final velocity is 0 meters per second. And 6 seconds is the time. and we want to know again what the acceleration is. Same variables I used in the previous equation, so I'm going to use the same equation, and since they asked for acceleration, I'm going to go ahead and use the rearrangement that I derived up here. So v minus v naught over t equals a. V was 0 again, and v naught was 36. We're going to divide that by our time, and so I get a negative 6 meters per second squared equal to my acceleration. So my magnitude is the actual number, and then the direction is the negative sign. So they didn't tell me a physical direction like north, south, east, or west in this example, so I can only report my acceleration as a negative 6 meters per second squared. All right, next question. A shuttle bus slows down with an average acceleration of 2 meters per second. I'm going to speed up my routine here a little bit. 2 meters per second squared is my acceleration. How long does it take? So what I'm trying to find is time. The bus to slow down from 10 meters per second, so that's going to be my initial velocity, to a complete stop. So I know that my final velocity is 0. Same variables, so same equation as I used before. And this time we're solving for time. So if I take v equals at plus v naught, rearrange to solve for time, that's just going to be v minus v naught divided by acceleration is equal to time. Plugging in my numbers, I get 0 minus v naught is 10 meters per second. I'm not going to keep that off. 10 meters per second divided by my acceleration, which was 2. And that's going to equal time. Now some of you might readily see that a negative 10 divided by 2 is going to give me a negative 5, and you can say we cannot have a negative time, and you're absolutely right. So what that tells me is that I left out a negative. The acceleration is actually a negative 2. How do we know? Because he was slowing down, and so he was going in the opposite direction, and since my velocity was positive, I know that I was going in the positive direction. If I'm going in the positive direction, that means my acceleration is negative. So negative 10 divided by negative 2 is 5 seconds is my time. That is the final answer for number 5. 6. A student is leaving the CHS parking lot after school. She starts her Porsche Carrera and accelerates uniformly for 5.32 seconds. So 5.32 seconds is my time over a distance of 195 meters to the north. So 195 meters, that is going to be my displacement. I'm writing delta x there because it is my change in position. She moved over a distance of 195 meters to the north. That is her displacement. What is the acceleration? Whoops, sorry about that. What is the acceleration of the sports car? So what we're trying to find is acceleration. So we have displacement, we have time, and acceleration. We need one more piece of information in order to use one of these equations over here. So we have delta x, we have delta x, which would be this one right here, and we have time. We want to find acceleration, we have time. Do we know initial velocity? That's the only thing I'm missing here to be able to use this equation. It says that she starts I guess we're going to have to make an assumption here. She starts her Porsche and accelerates. So I'm going to assume that she started from rest since she's leaving the parking lot. So what I'm going to say is that the initial velocity was 0. Now I can use that equation. Delta x equals 1/2 at squared plus v naught t. Now I need to rearrange for acceleration. So the first thing I'm going to do is realize that this is 0, so this whole part of the equation goes to 0. So I can simplify my equation to just be delta x equals 1/2 at squared. Now I'm going to rearrange to solve for a. The way I solve for a is I can divide by 1/2 or multiply by 2, because this is the same thing as this. And if I want the 2 to get to the other side, I multiply by 2. So 2 delta x. And to get the t to the other side, I'm going to divide by t squared, and all of this is going to be equal to a. Now I'm going to plug in my numbers. So I'll change colors and plug in my numbers. 2 times my delta x, which is 1/5, divided by my t, and then I have to square that, and that is going to be equal to my acceleration. So I'm going to punch that into the calculator. 2 times 195 equals 390 divided by 5.32 squared gives me a final answer of 13.7797. I'm going to round that to 3 sig figs. Why 3 sig figs? Because I have a number there with 3 sig figs, a number there with 3 sig figs. I take the one that has the least. They both have 3, so my answer needs to have 3 sig figs. So 13.77 rounded up to 3 sig figs is 13.8, and this is acceleration, so it's going to be meters per second squared. That is number 6. All right, number 7. A racing car reaches a speed of 42 meters per second. It then begins a uniform negative acceleration using its parachute and braking system and comes to rest 5.5 seconds later. Find the distance that the car travels during braking. Really, they want you to find delta x there. Even though they say distance, they really want to find displacement because the race car is going to be going in a straight line. So 42 meters per second, is that going to be initial velocity or final velocity? Well, it says they come to a rest 5.5 seconds later, so I know this is going to be my initial velocity. 5.5 seconds is my time. I know it comes to rest at the end. So my final velocity is 0. I know that I want to find out my displacement. I know that we have negative acceleration. So we have v, v naught, t, and we want to figure out delta x. So what we're going to have to do is we're actually going to have to do a 2-step problem. I cannot use this third equation because I don't know what the acceleration is. I don't know the value of the acceleration. So I have 2 unknowns there. I know v and v naught, but I don't know a or delta x, so I can't use that equation. And I can't use this equation because I don't know, again, a and delta x. So I'm going to have to use this equation first, the v equals at plus v naught, to find what a is. And then I can use the other equation to find delta x. Okay, so v equals v naught plus at. And we're going to rearrange to solve for a. So v minus v naught over t equals a. V minus v naught is 0 minus 42 divided by 5.5. So 42 divided by 5.5 comes out to be a negative 7.64. So my acceleration is a negative 7.64 meters per second squared. Now I want to find delta x. And I'm going to go ahead and add A over here. A is negative 7.64 meters per second squared. And then now, which equation do I want to use? Let's go back over here. I want to find, what are we looking for? Delta x or t? We're looking for delta x, and we do know t. So I'd say let's go ahead and use this second equation because it's already rearranged. It's already arranged to solve for delta x. So I'm going to use delta x equals 1/2 at squared plus v naught t. So delta x is going to be equal to 1/2 times a negative 7.64 times my time squared, which is 5.5. I'm going to square that, plus v naught t, which is going to be 42. I'm running out of room here. 42 times 5.5. I don't have enough room, but you're going to multiply that times 5.5. So what we're going to get is a negative value here, and subtracting that from the 42 times 5.5. 42 times 5.5. I get 231. And then 5.5 squared times 7.64 divided by 2 is 115.5. So this is going to be a negative 115.5 plus the 231. So 231 minus 115.5, we get 115.5 meters. So that's the change in our position for number 7. Number 8. Marcus went to Six Flags over the summer and rode Mr. Freeze. If the ride accelerated at a rate of 15 meters per second squared for a distance of 50 meters, what was the final velocity of the ride? So final velocity is unknown, so we're going to solve for that. And there's another variable that we can pull from this. We're going to assume that the ride started from rest. So we're going to say 0 meters per second is our initial velocity. So we want to know final velocity, and we know A and delta x. So what we're going to use is that last equation. This one here, v squared equals v naught squared plus 2ax. And that's because I'm missing time, but I have initial and final, and I have acceleration, and I have delta x. So let's go ahead and write that one out. It's v squared equals v naught squared plus 2a delta x. And now I'm going to rearrange for final velocity. It's already set up for final velocity, so this is perfect. I just plug in my numbers. V squared is going to be equal to 0 squared plus 2 times my acceleration, which is 15, times my displacement, which is 50. And now I get v squared. Oh, I have to take the square root, right? So take the square root of both sides. So I'm going to multiply 2 times 15 times 50, and then I'm going to take the square root of that. So that would be the square root of 200, and that's going to be 38.729. 38, and how many sig figs do I want? I have one here, or sorry, I have 2 here and 1 here. So technically 38.7 meters per second is my answer, but with the correct sig figs, I should only have 1. We're going to round that up to 40 meters per second would be the final correct answer. So that's our acceleration worksheet. If you have any questions, let me know.